I built an AI that learns to play Snake from scratch. No pre-training, no cheating. There's this old idea that it takes 10,000 hours to master a skill. So I gave an AI 10,000 games instead. The rule is simple. Good move, digital key. Bad move, punishments. At first, it's an idiot. Give it a few thousand games and it starts doing things I never told it to do. So let's get to building it. Before an AI can learn Snake, Snake has to exist. So step 1, I built the game itself. Grid, Snake, food, collision. Nothing fancy, just spy games. The one thing that matters here is this collision check. Hit a wall, hit yourself, that's death. This function gets called constantly later because it's basically the AI's sense of danger. Right now though, player controlling this snake has 0 brain cell and time to fix that. This is reinforcement learning and the whole system runs on rewards. Eat food plus 10. Hit a wall or yourself minus 10. That's the punishment. But here's the trick almost nobody talks about. If you only reward eating and punish dying, the AI figures out it can just survive by spinning in a safe little circle forever. Technically, it's not losing. Also, technically, it's useless. So I added a tiny penalty, minus 0.1 for every step it takes. Now, standing still is also a losing game. It's forced to actually go for the hunt. 3 rules. Eat, don't die, don't stall. These are all the rules that AI has to follow. But even with perfect rules, this snake is completely blind. It has no idea where the food even is. A neural network can't see a game board. I have to translate everything into numbers. So every frame, I calculate 11 values and feed them to the brain. Is there a danger straight ahead? Danger to the right? Danger to the left? Which direction am I currently moving? And where's the food? Those 11 numbers, that's the whole universe as far as the AI is concerned. Those 11 numbers go into PyTorch neural network. 11 inputs, a hidden layer of 256 neurons and 3 outputs. The outputs are just 3 choices. Go straight, turn right, turn left. The network does the math, picks whichever option it thinks scores best. This is deep Q learning. The model is literally learning to predict which move gets the highest long-term reward. So now the brain is built, but there is still a problem. It's a brain with the intelligence of a rock. It needs to actually play or practice. So I connected everything. The agent holds a memory that stores every state, move, and rewards it's ever experienced, up to 100,000 of them. Early on, the AI mostly makes random moves on purpose. That's exploration. It needs to try dumb stuff to learn what's dumb. Over time, the randomness fades and starts trusting its own prediction more. One command to launch it. 10,000 games, let's go. Game 1, total disaster. It does not know what a wall is or a food is. It's just going round and round in itself and it's trying to figure out and it's crashing in itself. Game 100, it has figured out that food equals to reward. So it's actively hunting for food now. Game 1000, there is a clear improvement. It's dodging its own body, scoring consistently and making sharp deliberate turns instead of random ones. Game 5000. This is where it got weird. It starts leaving itself a little escape corridors, weaving in tight patterns to make sure it's never boxed in itself in. I never coded that behavior. It found it on its own, just by getting punished enough of the times for the alternatives it has tried. Game 10,000. And this was something I was surprised by. The difference between game 5000 and 1000, the score difference didn't vastly change. As you can see in the data I have stored in a CSV file and also build a dashboard on it, it hasn't changed much. So what's happening here is, what we see is from 5000 to 10,000, the training really does not matter. It just changes the scores from 1 to 2. But if we were to train it for 100,000, maybe the score would have been better. To answer the question, does the 10,000 hour rule hold up for an AI playing Snake? Pretty much, yeah. 10,000 attempts turned a random wall crasher into something that plays like it actually understands the game. And that's the whole pipeline. Game environment, reward shaping, state representation, and deep Q learning, tying it all together. Subscribe and I'll see you in the next one. Happy coding, keep coding.